In mathematics, whatever we do, we need to be able to undo. So if we have addition between two things, we undo that by subtraction. If we have multiplication between two things, we undo that by division. Exponentiation, we do a radical. If we have a function, what do? So the idea with a function, again, is that we put in an x and we get out a y, right? And then if we want to get x back, we have to be able to undo whatever we did to get to y, right? And the process of undoing a function we call an inverse function. Okay, so we're going to talk about inverse functions as we kind of develop our tools around functions in general. And so to motivate that idea, here's an example, okay? The example is talking about a disease moving through a population, and we assume that the population is in an isolated city, okay, and nobody is immunized beforehand. And so if we look at this, let's see, so it says we're counting the number of individuals in thousands, so the numbers that we see here are actually thousands of people who have contracted the disease by day T after the first case is reported. Oops, typo, 1E. And so we have that function. And then we have a series of questions, okay? So part A is saying how many people have contracted the disease after 1 week. Well, T is the number of days since the first case is reported. So all I would have to do is evaluate n of 7. So stick n into the 7 into the function. We have 200 over 1 plus 2 to the exponent of -3, and then 7 minus 5, like that. And then I just have to go through and do the arithmetic. So this is 196.9. Okay, well, we can actually go a few more decimal places because we have to say, okay, we get this number out at the end, but really this is meaning that there's 196,923 people that are infected. Let's see, infected or that have contracted the disease after 1 week. Okay, so we can do the calculation, there we go. But if we're asked about how many have the disease after 1 week, substitute it in the time value and see what we get out. Part B, what is the domain and range of this function? The domain, right, is a set of all inputs. And so then we're thinking about T, so T would be all the possible inputs that we would have, and we would have to look at the denominator, formally speaking, for the domain and just make sure that this is not 0. I can tell you, we can go through and investigate it further. It's never going to be 0. So we would think that the domain is going to be all real numbers, minus infinity to infinity, right? However, t is time, right? We can't have a negative time, so we would say time would be from 0 to infinity. Now the range is always a little bit of a tricky question. What I would do is I would say substitute in 0 and see what we get out, substitute in 1, 2, 3, 4, and a very large number, right? Kind of see what this domain would do. And if you do that, your range is going to be 0 to infinity, exclusive on both, okay? You could also put this into Desmos or something and look at a graph too and analyze it based on that graph. That's just fine. Okay, part C, how long does it take for 100,000 people to contract the disease? I'm kind of running out of room, so I'm going to kind of come out here. So there's this 100,000 people. Oops. And so this is the number of people infected. And so what this really means is that n is equal to 100, okay? And notice it says how long, right? How long? This is asking for a certain time, right? The number of days, perhaps, okay? And so what I'd have to do is I can use this information, but I'd have to say, okay, my n of t function, I'm just going to copy it down here, 200 over 1 plus 2 to the power of -3 t minus 5. Okay, I am trying to solve for t. I want to know what t is. Well, this is a difficult task because t is trapped in some things. So I could do like 100 is equal to 200 over 1 plus 2, negative 3, t plus 5, t minus 5 rather. Okay, and then I can do, this over 1 and do some cross products. Okay, so I'd say 200, so that cross product is equal to the other cross product, 100, 1 plus 2 to the negative 3, t minus 5. Okay, and then my algebra skills can help me here. Divide by 100. Okay, 2 is equal to 1 plus 2 to 3, negative 3, t minus 5. Okay, subtract 1 is equal to 2 minus 3, t minus 5. Okay, now this might take a little bit of work. We put it in and solve, but what we end up with is that t is equal to 5. Now, I'm not so concerned that you know how to solve this. We'll come back and see more functions and equations like this later in the course, but the idea is I was able to start with an n value and go and solve for t, okay? So that's that idea of, in part A, I was given a t value and I was able to calculate n. Now I went backwards in part C, okay? So that's the idea of an inverse function, okay? And finally, part D is asking, okay, we have a function n of t, and then I'm telling you it is possible to find a function t of n. So again, that's kind of what we're doing in what we did in this situation. We were given a value of n, right? And we solved for t, okay? So we're not worried about the exact mathematics and how to do that right now, but we're just curious, like what it would mean, right? If we think of that function t of n, okay? What is this describing? See if you can describe it to yourself. Okay, well, t would be the time, right? So it would be a function giving time. So we're getting time given a number of people who have contracted the disease. Okay, so we're inputting a number of infected and we're getting out how long it would take to reach that point. Okay, and so that's the idea of an inverse function. We will see more properties and mechanisms related to it, but at least we have the basic idea where we are given a function and we can calculate it forward, but we also want to be able to calculate it back in certain instances. Okay. The other videos, we will look at other properties and details related to inverse functions.